Alright, let's do this. Hello, I'm Tom and welcome to the show. Today we're back doing PlayStation 2 dev. It's been a little while. I think it's been about a month since my last stream doing this. So let's get in. Let's remember where we left off, first of all. Let's move this over here. Just a few quick things to configure. So I've done a little bit of work. Sorry, I've done a little bit of work off camera here. If we pull up, so I started refactoring things to work with Lua, and it got a little bit messy. Wolf, hello. Thank you very much for stopping by. My refactor got a little bit messy, okay? Changing everything over to Lua was hard, and I came up with an example of what I wanted it to look like, and it wasn't very good. So I've rewritten my example, okay? And so this right now is what we're building towards, right? This is a much lower level abstraction than what I had before. So we've got a few different parts here, right? We're gonna have our interface to setting up the graphic synthesizer, the main kind of rasterizer of the PlayStation 2. We're gonna have this done through Lua, right? So even, you know, in the distant future when we do things in like very optimized C, maybe have to write some like super optimized assembly to do powerful rendering, whatever, our main interface for configuring the hardware initially will be in Lua. That is a commitment that I'm making, right? So we'll do things like allocate frame buffers from Lua, because it doesn't matter if there's, you know, kind of a cost of doing this in Lua, of it being more expensive, of there being like, you know, the cost of having to decode arguments from Lua into C, whatever. You do this once, and then you just go. So yeah, we're going to keep some things like this on the Lua side. You know, setting up the graphic synthesizer, we're going to have like a scene abstraction. We're going to be able to load things into a scene. We are going to have an interface for building up draw buff. Oh, well, we're going to interface for like building up our scene in Lua. More importantly, we're going to have an interface for building up the actual contents of a draw buffer that we then send onto the graphic synthesizer from Lua. And this is going to mean that we can really quickly iterate, we can build tests, we can have a bunch of scripts that describe different things. Rather than having to have a bunch of cumbersome C files, hopefully we can just have a few simple loops that look more like this, that are more manageable, that are easier to iterate on, and that we can very easily run, you know, like a suite of tests in sequence, run this script, run this script, run this script, visualize a bunch of things, confirm that things are working how I believe they should work, and, you know, potentially like, potentially try things out in a much more flexible way. That's the goal. That's the goal. I also think I was working towards something too big, and I need to think about the scope of what I'm doing, right? So this gives me a really clear goal. So as it stands, I've pretty much implemented the GS side of this. So if we pull up my new GS Lua, it's pretty ugly, okay? We have this big global table. It has a couple of constants in it that come from PS2SDK. And it has one main function, which is going to be this kind of new state that we use to create a Lua state. Where are we? Set buffers, where are we? New state. And so, you know, this takes in a few arguments for, as we can see in our example, it takes in dimensions of the screen, it takes in if we're interlaced or non-interlaced, it takes in a video mode. These things get, you know, decoded using the usual Lua stack magic, and you know, we kind of set them up. Sorry, they get decoded up here. They get stored into a table that we're eventually returning. We're not using meta tables here yet. We will at some point in the future, probably. But for this object, like, you know, we're only going to create one of these probably per program. They don't do much. So, I don't know. The C interface for meta tables is like a little bit more clunky. We're going to roll with this for now. And then, yeah, we can actually, you know, create some frame buffers and bind them to this state. And this is a lot of like decode things from a table and then pop it off the stack into C where we can use it. There's a lot of this, right? A lot of boilerplate to get this working. And I haven't actually tested it yet, but, you know, it's the same kind of logic and it should work. There are a few missing pieces to, I think, really actually test it. The main one being a draw buffer that we can just pipe a bunch of bits into and get something on the screen. So that's the next thing to really approach. And funnily enough, what have I called it? Draw. I just called it Lua. What have I called it? I've got a file in here somewhere. It's not, I think it's draw lua.c. Yeah. And here I am actually doing some metadata stuff, right? I'm using the lua L extensions. I don't know what the L stands for. Lua large, the lua that has extra stuff in it. I'm building a shared PS2 buffer type that we're going to use for building up arbitrary chunks of data. And the interesting thing about Lua, and this is one of the first kind of headaches I've hit, is that Lua seems to play fast and loose with how wide an integer is, right? So I can't say if I jump across into our C code, do I still have just some arbitrary... I've gotten rid of it all, haven't I? It's all in draw now, isn't it? Draw.c. You know, we're writing a huge chunk of arbitrary data into a buffer, right? I don't know how we can do this in Lua. I don't know what the interface for this looks like in Lua. You're studying Lua for PS2. Awesome. Yeah, I think Lua for the PlayStation 2 makes a lot of sense. I don't know if I will be building entire games in Lua or how much of a game I will be building in Lua, but I think it makes sense to have as an interface. And it seems like there's a bit of interest in PlayStation 2 Lua, which is really cool. And, you know, Lua in general, right? Awesome language. Highly recommend looking at it. But yeah, basically we're gonna like go through absolute hell sorting out what... This isn't gonna be a fun few streams. This is gonna be a tedious few streams. This is gonna be a lot of looking at just like stuff. But it's gonna be awesome when it works. So actually, we probably could compile this and run this out the bat. I think we have enough to initialize the graphic synthesizer and write transmit a draw buffer that does nothing. The only things missing, I guess, are the DMA code, right? The code that actually starts up the DMA controller and then sends a buffer over DMA. So that's probably a good place to start the stream, right? I feel like I might have something missing here. Maybe. But yeah, the main idea with having a meta table for our draw buffers here as well is that, well, for our buffers, sorry, I need to be very precise with my language here. We're going to have buffers and we're going to have draw buffers. They're going to have the same interface, but a draw buffer, because we're going to need a draw buffer every frame, we're just going to have one big dumb buffer that always stays at the same place in memory. And this is not the best way to work with a PlayStation 2. We actually had problems with this before. I'm going to make this non-static. And I'm actually not going to pre-allocate it either. That's actually, I'm glad I thought of this. But we're going to just have some, like, you know, some block of memory that's always there, and every frame we just get it. Rather than playing around with, you know, trying to, like, find a contiguous block of memory that's big enough for us to fill with frame data. No, forget it. Big dumb block of memory that we can probably actually configure, right? So what we probably need to do is have an argument to when we initialize this. So when it sets up the meta table and stuff, also just make sure we actually have memory for a draw buffer. Wolf in chat says it's too much easier than C++. Used to programming in C#. Yeah. I think for me, it's always going to be a hybrid, right? I want a good Lua interface, but I also want to be able to write I want to be able to prototype things in Lua, but then swap to writing highly optimized C code when I can, hopefully with as little pain in that transition as possible. So I guess, you know, for example, let's go... I've learnt a few new Vim tricks, by the way, in the last month. The main one being that I'm using Fuzzy Finder now, so I can, like... I've got the open buffers Fuzzy Finder command bound to, like, just pressing space twice, so I can really easily swap between things. It's cool. Highly recommend learning about Fuzzy Finder if you're a Vim fan like me. Can't believe I hadn't done it sooner. I'm also using C tags now, but I'll do a bit of a demo of how cool that is later. But yeah, you know, like for example, I can write this code, I can write this loop out in Lua and prototype it and go, yeah, okay, this works. You know, I've got this interface into like doing our transforms and stuff. But then I can eventually replace this with a function that just says build scene. And you give it a draw buffer, and you give it a scene, right? And it does all of this just on the C side. I think that's going to be really important. I think that's going to be really, really important. So let's think about getting something that actually runs, okay? So let's copy our example, and let's get a minimal working product, right? So We need to initialize our DMA controller. We need to initialize the graphics synthesizer. We've already written this code. I've already written this code off camera. We don't need a scene. We don't need a camera. We don't need any of this stuff. We need to tell the program what GS state we're using. I don't know if this is really necessary, but we're gonna keep it for now because I think it's a bit more precise. Our onFrame function gets whatever graphics synthesizer object we have bound. Again, this is a little bit imprecise, I think. It may be more idiomatic to maybe say gs.onFrame equals something, to actually have an onFrame function in this graphics synthesizer instance, I guess, maybe, and then say gs.run or, gs.run. Like, maybe something like that could work, but I would rather keep our main loop. I would rather have more control over my main loop, I guess. So this is what we're going to do for now. And then per frame, all we're going to do, we're going to get the draw buffer. We're going to write the information we need to start a frame into that buffer. We're going to draw nothing, and then we're just going to end the frame. We're going to send, and then we're going to say, hey, we don't need this buffer anymore. Perfect. That should be good. That should be good. And then, yeah, we need an exit as well. This is a little bit of a weird line, isn't it? Right? Because I don't know why we would call exit if we've already like triggered an exit. Let's just get rid of that. Let's just get rid of that. Okay, so this should be a minimum viable a minimum viable program in Lua that we can run. The things that we need to do are write this DMA glue code, write the actual like main for it. God, this is going to be a messy branch. This is going to be a messy branch. And there's going to be a lot of pain getting things back to where we were a month ago. But it's going to be worth it. It's going to be so worth it when we can iterate faster, when I can like more comfortably... It's going to be good. It's going to be worth it. It's going to be worth it. We were at a point a month ago where I had to implement a scene abstraction anyway. If we can offload more of the, I guess, grunt work of that into Lua for the time being, just so I can prototype and experiment, it's going to save a lot of headaches. Sorry, it looks like I've got like a bug or something on my audio interface.
What?
Yeah, there's a moth chilling out on my volume lever. Okay, well, he can stay there. That's fine. I hope he lives his best life. So, what am I doing? What am I doing with my life? What am I doing with this code? We have this stuff. Draw. Source. Lua. No, I could have draw Lua, didn't I? So, push int copy. So yeah, this is going to be messy. This is going to be messy. But we'll implement something that gets the job done for now. So static int draw Lua. Oh, well, we're going to call it buffer. Sorry, buffer push int. It takes Lua state. And this is going to be pretty simple. This is going to get the second argument on the stack and write it into, if we come down to our actual like draw buffer being created, we have this pointer, which is the actual memory, the actual array that we're writing to, the raw byte, or the address of the bytes we're writing to. So what we need to do, we need to say int value equals Lua dot to integer. Sorry, we want positive 2 because it's the second argument. We're gonna grab, so we've got the value, we need to Lua, what do we say? We say Lua dot Lua gs Lua. What do we say? Push string, that's it. We've got to write the string. Because Lua string. Lua loves its stack to actually like dereference a field from a table, right? You push the name of the field and then you say get field. Beautifully simple interface. I really love it. I really love it. We are gonna get the pointer field. We're gonna say Lua dot get table L. We're gonna get the first argument on our stack, Lua. Now we say this is to light user data, L negative. So this pops the Lua object onto the stack in position -1, and then we actually kind of dereference this off of the stack into, well, not dereference. We transfer it from the Lua world into C world, right? Or we transfer ownership from Lua world into C world, I guess. That's a really janky way of saying it. So we have our pointer now. We probably actually want to get this as like a char array or something, anything other than void, basically. And we have an integer. We have what is probably a 32-bit integer, I hope. So we're gonna treat it as a 32-bit integer, right? That's where we're gonna start here. Push int value. So we want to say as well. Okay, well, hold on. We can simplify. We'll actually get this as an int array. We want to say we need to get the head. So our buffer's actually going to store like it's going to get filled up from the bottom. The idea in general is going to be that we fill them up and then never take anything out of a buffer. It's like a stack that never pops. So we need to get the head as well. Lua push string L head. Lua get table. And then int head equals Lua to integer. Cool. So just the same as we did before. So we've got the head, we've got the pointer. We should also check the size as well, but we're not going to do that yet because that's for nerds. We are going to say pointer head. Let's see, what's going to be hard is if the head isn't aligned to the width of an integer. So for byte int, if head is going to be a number of bytes, so if head modulo 4 is not 0, then we have a problem. Because you can always handle this. You can always write this int still. It just takes 2 writes instead of 1, and you have to like do some bit masking. But I don't want to do that right now because we're only ever going to be using this oh no, we're not. Well, we're not even using this interface yet. I just think this is a good, solid function to have, and it's going to be a fun way to play around with these buffers. I want to have this. Because everything we do on the PlayStation 2 is going to work in quad words, in 128-bit chunks. We can assume this is always going to be 4 bits, so that's going to be fine. I've actually forgotten what our error logging functions are called. Fatal error. Yeah, well, of course I don't have any in our main. Our main just like crashes, right? Log. Log error. There we go. So let's go back to draw Lua. Manually bit mask, etc. Buffer. But yeah, we'll just conveniently ignore it. And we'll say we return 0, there is nothing left on the stack. Yes. Oh, a few viewers coming in. Welcome. I've been spam advertising this in the PlayStation 2 Discords. Seems to grab a few people's attention, which is really fun. It's cool to get some PlayStation 2 interested people coming along and checking this out. So, yeah, we're not going to handle this yet. And then we're just going to say pointer head divided by 4. Wait, is the head the head starts at 0? The head starts at 0. When we write something, we write to 0, then we increment. Yes. Equals value head plus equals 1. Then we need to write the head back. So Lua push integer head plus 1. Is it actually? Am I having just like a moment here? Hold on. Hold on. Is all of this pushing? Yeah, good. Lua does have an integer type. Lua does have a... Because Lua has a push number as well, and I think behind the scenes Lua numbers, I don't know. I'm not gonna fly to my depth. Also, very important thing. Hold on. Where are we? Dot. Perfect. I always forget to set my desktop background. I really need to make sure. I think I have that in my XRC, but it never seems to run for some reason. So that's important. That's important. Very important to me. Okay. So we need to just do a magic thing to write this back to the table. Lua set field. It's the table in position 1 because it's argument 1, and it's head. Perfect. So we update the head. Easy. And we should also update... Well, the size is the total size. So yeah, we need to check the size at some point as well. We're not going to do that right now. Okay, so we can write... and we return 0 because there's nothing added to this Lua stack. So we can write arbitrary data to our buffers now, which is cool. What was the other thing I'm missing? The other thing I'm missing is buffer copy. And this is actually just going to be log 1, I think. Or just info. Just info. Info unimplemented. Cool. So if you try and copy 2 buffers together, no good. No go. Beautiful. So it looks like we've got everything we need here. Other than allocating this. So that's static draw buffer. Static draw buffer. Let's go info. Allocating. How big do we want a draw buffer to be? Should we say like 2 kilobytes, 3 kilobytes? Let's go 2 kilobytes for now, and we'll see if it becomes a problem later. Cool. So we're missing a bunch of headers here, by the way. We're missing a bunch of headers. This file doesn't actually need any PS2 SDK stuff, which is good. That's kind of cool. Oh, hold on. We actually have a frickin'... we have a thing for that. We have a thing for that. That can be static. Okay, so... draw buffer max size. Okay. There we go. I thought I was losing my mind a bit there, but we're good, we're good. So now I need to remember what headers I actually need here. So let's look at the thing I was doing before, right? So this was my last refactor attempt to get Lua into this, and it kind of sucked. So we're gonna probably just delete that file soon, or at the very least just ignore it. But we're gonna copy from it where we can. So PS2, we don't need this, we don't need this. We don't actually need anything here. This has no dependencies other than Lua. This has no dependencies other than Lua and log. So log.h. I really should make this one that actually gets like, you know, not one that's actually on the include path. I think that would be a lot cleaner because it gets included just absolutely everywhere. And I think this is okay. Start frame, end frame. New draw buffer. Yep. Yep. I love it. There is also... Have I not? Oh no, hold on. Min. There is also free that I need. So, Lua push C function. God, this naming is a bit of a nightmare. I'm gonna have to revisit this. Set field L -2 free. And yeah, like I was saying, right, our draw buffer is just one blob of memory. We never actually free it. It always just stays there. We don't worry about managing it because we need it every frame. So static int draw buffer free Lua state L. We do nothing, right? We just do nothing. Maybe we just need a function called like unit or something, right? Lua unit. Is there a default null or nil Lua function that just does nothing? Hold on. Let's answer that very question. Is there a default Lua C function that does nothing? No one else has ever asked that exact question before. I think that's one of those things where it's like, no one has ever put that combination of words together before in the history of anything. So we're gonna do that. We're gonna do that. That's gonna be great. And this is gonna drop off of the universe, right? Once this falls out of scope, Lua's gonna garbage collect it. But add user data, aka we tell Lua that we manage this this pointer from our C side, and we just use a dumb static buffer, which is always grabbed like the exact same dumb buffer every time we call new draw buffer, which you should only do once per frame at the beginning of a frame. There's nothing to stop you doing it more times, but if you do, that is on you. So this is part of our draw buffer contract, and this needs to be documented somewhere. So that is, again, a really good candidate for a to-do, right? To-do, document, this can only be called once. Okay. So we've got a buffer. Let's go back to our minimum example, make sure we're on track, okay? This, perfect. This, perfect. Nothing else we need to do. DMA, let's do that. So let's go source DMA lua.c. Okay. What are our functions? What are our functions called? Init and send buffer. DMA init gif hello and hello static int DMA send buffer. Perfect. These are gonna be our Lua state structs. If anyone in the chat, by the way, has any strong opinions on Lua, because I really don't have many strong opinions on Lua, capital L or lowercase l in this kind of C API function definition, is it a big deal? Am I gonna start, like, accidentally kick off some kind of religious holy war over this? I like lowercase l. I think it's a little bit cleaner. I don't like having to press the shift key down all the time when I'm working, and especially, you know, like some of these functions get super, super wordy. You refer to the Lua state just absolutely all the time. So I prefer lowercase, right? Interested in if people have opinions. Okay, we've got to head over to our old main function, our old friend. Our old main function, which is not going to hang around for much longer, because we're going to just replace it with Lua. It's going to be beautiful. It's going to be seamless. But we've got a few things to do first. So here we go. See, again, we could probably provide like a lower level interface here. I don't know what we really want. It seems like my thoughts are kind of spread, right? Because, min, I should say. Where are we? There we are. Okay, it seems like my thoughts are a little bit split, because here I've got a function that's very, you know, kind of higher level. We're just saying what we want to initialize, and we write the C code that does it. But down here, we're actually kind of saying, well, I'll tell you, I'll tell you what's going on. Just one second. I'll be back in a moment. Oh, oh, that was very exciting. My partner made nuggets. Fantastically exciting day. Who doesn't love a good oven fresh nugget? So DMA. I guess what I was getting at before is, right, we could actually just say, rather than DMA init GIF, we could say DMA.init DMA.toGIF or DMA.channel GIF or something like this, right? I don't know if this is the best interface. I don't remember what these numbers mean. And actually, here's a great opportunity for me to showcase C tags, okay? So again, if you're a Vim lover like myself and you've never used C tags, super easy. So here's PS2SDK. I've got a file here called tags, which is what I've generated. Let me get rid of it, okay? So here's what you do: C tags, recursive, and you run it on like the whole directory, and it generates a tags file. Vim knows how to step through this, and these are all of your definitions, right? So like, it lets Vim understand how to jump to a definition of something, right? So if I open up Vim now and I open up the fuzzy finder tags interface, I can type in the name of a tag. So what's this function called? DMA channel initialize, and here's the definition. That's simple. I was using grep for this before, and that's pretty cool. Saltrack, thank you very much for the follow. I was using grep for this before on the command line. It's honestly so much nicer just doing this all from within Vim. Highly recommend it. Okay, so DMA channel initialize, a handler. This is an interesting argument, and then we also have some flags. I don't know what the flags do, right? So this, interesting. Clear any saved DMA tags. Yep. So it's just gonna clear some stuff out. I wonder what this handler does. Fast wait, waits fast. I love these weird little inline assembly blobs. Makes me very happy. Okay, so in conclusion, we probably actually can just say, we probably can just do what I was saying, right? And just say DMA init DMA.gif. And then when we say DMA send normal, we say probably say DMA send buffer normal, right? We'd be a little bit more precise with our language. Well, how many DMA things are we using here? DMA wait fast. That's probably important to have as well. Or is it? See, again, I'm not totally sure if we want this in the main loop from the C side or if we want this in the main loop from the Lua side. I guess we'll do it from the Lua side for now. And my general approach is going to be do everything in Lua until it's a problem and then move it to C. That's my thought. That's my vibe. So. What am I doing? We're going to go back to DMA Lua. We're going to add a function called static DMA wait. I guess we'll say wait fast. We'll be precise. And we're going to change this to DMA init. Okay, so int channel equals. We're going to pop the first argument off of the stack. That's going to be the channel that we're actually like DMA sending to. We are going to just call DMA. What was I searching for? Hello? DMA initialize. DMA channel initialize. We say channel, we say 0, and we say 0. Was there something else I did? Oh yeah, DMA channel fast waits. We'll do that as well. Can't exactly remember why, but we'll do that as well. This as well, this is going to be basically the same function. Oh, and we return 0. We don't put anything on the stack, we return 0. So we're going to grab this definition. We're going to do pretty much the same thing, except we're just going to say DMA channel Wait, this doesn't actually take an argument, does it? Hold on, hold on, whoa. Whoa, 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 whoa. Fast, wait. Wait, fast. Yeah, this doesn't take an argument, okay. I'm being silly. DMA, wait, fast. Yeah, and this is again one of these things that's just a weird arbitrary blob of assembly. And so then we just need to be able to send a buffer. This is going to be a little bit more interesting, I guess. So what order do I have arguments in? That's going to be important. Min, not main. Buffer, and then the channel. And we're just yelling out channel names now. Nothing too fancy. Okay, so we're gonna, so buffer is arg1, channel is arg2. So we know how to get the channel, right? We've done that before. Lua to integer. Hold on, I'm very silly. That's stack position 1. This is argument 1. L argument 1. Cool. And then we need to lua push string. The string is pointer. And then we say lua get table L. The table is in position 1. And then we say lua to light user data L. We say, let's get this as a void for now. We're gonna cast this to a quad word T eventually, so we're just gonna treat it as a void pointer for now. That's gonna be cleaner. Anakin Luke, welcome. Thank you very much for stopping by. It's good to see some familiar faces. You like my stream? I like my stream. It's a good stream. It's getting better every time. Okay, so. We've got our list. We also need the head, because we need to know how much data we're actually sending. So lua push string L head. Lua get table. Hold on, I need to actually. I forgot. And then head lua to integer L -1. Right. Just plus play to say hi. No, thank you very much. It's awesome to see familiar faces in. Always welcome to just come by and say hello. You're never obligated to stay. Have a good day. So yeah, when I'm doing this Lua stuff, I keep forgetting to give an argument to these functions. The argument here just tells Lua where to look, right? So we're saying get the thing on top of the stack. So we've got the head, we've got the pointer. Now this head is in number of bytes, right? So I guess head's an awkward name for it, right? I'm thinking of it as like, it points to the head of the array of bytes. Or I guess it's what you add to the pointer to get the actual head. Maybe a bit of a terminology mishap here. Maybe we can come up with a better name as we go through. We'll have to see. So, quad word T. So we treat it as a quad word T. I guess it doesn't really matter, right? I guess it really doesn't matter. If we head back over to main where this stuff happens, right? So we get our buffer, we do our transform, we add things to it. Q T Q. Okay. Frame and send normal. So when we send normal, we give it a channel, we give it a buffer. So this is fine. We can just give this a void pointer. It'll kind of cast it to a keyword T behind the scenes because C is very relaxed about this. And then we give it the number of quad words, right? So the number of quad words in our case, that's actually not going to be hard. Man, I don't know why this window up here keeps stealing my focus. That's very annoying. The number of quad words is just going to be head divided by 8, right? Right? Because quad word. Quad word is 128 bits. Each number in head is a byte. So it's 8 bytes. No, wait, it's 16. It's 16 bytes. Quad word. 4 words. 4 32-bit words. Sorry, it's 16. It's 16. Factor of 2 out. Nothing, no huge deal, just a factor of 2. Okay, so DMA, channel, send, normal. We give it the channel ID. We give it the buffer, which is our pointer. We give it the number of things that we're sending, and then we give it 2 zeros. What do those zeros mean? I don't know. No one knows. It's a mystery. Let's have a look. And let's use our awesome... why does this keep stealing my focus? That's so annoying. Send normal. Call to account, flags, and SPR. SPR. It's something I'm going to have to learn about eventually. What does this do? It's a bit of a mystery. Okay, but it sends things between hardware components in the system. That's perfect. And it also tells me that I don't have to worry. I can just set these things to 0. So, that's all we need. And this should... the other thing we're missing... These are all of the like C implementations, right? But we also need the DMA, Lua... this is awkward because we have a function called init, and then we also want to like init the actual Lua library, right? We need to give something that's going to set up this global table. It's going to set up this global table that we see min. God, really hard to type min when you've got main on the brain. This global table here, right? We need to actually set this up. So, DMA. Lua, create table, L, Lua push C function. We're gonna set up this stuff first. DMA wait fast, Lua set field, L, -1, no, -2, right? So table gets pushed onto the stack. This gets pushed onto the stack. The table is now at index -2. We set the field of the table to the thing on top of the stack, and the table is at index -2, the second index from the top of the stack. We set this to wait fast. We push another C function. And there are probably libraries that make this a little bit less verbose, but honestly, like, it's a lot of typing, but it's very simple, and I would rather keep dependencies low, even if it means a bit of dumb grunt work for me at the start. DMA send buffer. This is going to be called L -2. We're going to call this send. We're going to call it send. We're just going to call it send. We're not going to complicate these names, right? We're not going to put junk in these names that isn't necessary. L DMA init. It helps if you actually wrap things in double quotes and don't misspell them. Just a nice little tip. Set field. This is we're just gonna call it init. We're just gonna call it init. And now Lua set global. Is this what we do? Is this a real function? It feels like a real function. It tastes like a real function. Let's check out what we're doing in GS Lua. Set global. Yes. And I think this pops as well, right? So that should be fine. That should be fine. Okay, this is good progress. I am unfortunately going to have to call it. I was hoping to rush through and get something to run, but I am going to have to call it there. We are disgustingly close to getting something to work. Now I'm going to be back, and I'm going to be back a little bit later today. Probably in like 6 or 7 hours, something like that. And I'm going to do a bit more streaming, a bit of a longer stream. But I thought I just wanted to get this work started, right? It's been a little while. Sometimes you just need that first stream, get over the hump. So thank you everyone who stopped by. This has been fun. I have some nuggets to go and eat, and I will catch you next time.